Hello viewers, Wagadaru now taking you through the story of O-Level Physics Paper 2. And this video I'm going to go through the solutions for O-Level Physics Test 1 of Senior 2, and the topic was machines. So this topic is in mechanics and is suitable for students in both in Senior 2, Senior 3 and Senior 4. So just start with question 1. Question 1 part A says, explain why the fulcrum must be nearer to the load than the effort in a first class lever. So you come and say that when the effort is far from the fulcrum than the load, a bigger turning effect is produced and a small effort is used to overcome the load. So the reason is to be able to use a smaller effort in order to overcome the load. So that was part A. Now we shall go to part B. Part B says the figure below shows gear wheels. So this is gear wheel A, gear wheel B. Then they say that explain how A and B should engage to give a turning effect force of low mechanical energy. So A should be the driving wheel. No, that word A should be the driving wheel and B should be the driven wheel. And this makes the wheel A to move with a higher speed, hence mechanical energy is low. So for you to make mechanical energy to be low, A should be the driving wheel and B should be the driven wheel. So that was part B. Now we shall go to part C. Part C, Roman 1 says, draw a diagram of a single string pulley system with velocity ratio 6. Now velocity ratio 6 means that the number of ropes pulling are 6 and also the pulleys are pulling pulleys are 6. So let's try to draw it. So the upper part of the pulley will have 3 and the lower part of the system will also have 3 pulleys. Then we shall now put a string. The string must start from the lower pulley, from the upper pulley, going downwards in this form. Like that, because it is a single pulley and up to there. But it must be tied, therefore it must be straight and vertical. So let's try to draw it in that form. So the order of the pulleys is also the order of the ropes matters. You start from here, go to this, and from here the rest of the ropes must be vertical. Know that word, vertical. That is why the pulleys in between were smaller. They went on increasing until the last one, which are bigger. So this is now the effort. What about the load? The load will be there. Now because these strings are tight, that means that there should be some tension in between them. So we shall put the tensions there. The tensions are arrows facing upwards on each string. So for this it is there, for this it is that, and for this is that. So that's how marks can be awarded for this slide. Now we shall go to part C, Roman 2. It says calculate the efficiency of the pulley system in B Roman 1 above if an effort of 1000 newtons is required to raise a load of 4,500 newtons. Now the good thing we already have the velocity ratio, which is 6, and since we have the load and effort, we can get the mechanical advantage. So mechanical advantage is equal to load over effort. Load was 4,500 and effort was 1,000. So when I divide, I'll come up with 4.5. Then I remember that efficiency is equal to mechanical energy over velocity ratio multiplied by 100. So mechanical energy, we have got it as 4.5. Velocity ratio was given as 6. So multiply by 100 to come up with 75%. So that was Roman 2. Now we shall go to Roman 3. Roman 3 says, find the energy wasted when a load of 1,500 newtons is lifted through 2 meters by the pulley system in B Roman 1. So now we have this load and we have the load distance as 2 meters. Now they want the energy wasted. So work output will be equal to load times load distance, which will be load is 1,500 and load distance is 2 meters, which gives you 3,000 joules. Then I remember that efficiency can also be defined as work output over work input multiplied by 100. Therefore, since I know the efficiency, I'll come and substitute for efficiency and also for work output, and I remain with work input as the only unknown. So when I make work input the subject, I'll come up with work input as 4,000 joules. But remember, they wanted energy wasted, so energy wasted will be work input minus work output. So I'll come and subtract 3,000 from 4,000 to come up with 1,000 joules as the energy wasted. So that's how the marks would be awarded. So that was question 1. Now we shall go to question 2. Question 2 says, part A, the diagram in figure 2 shows a pulley system used to raise a load. Roman 1, what is the velocity ratio of this system? So velocity ratio can be got in 2 ways. One, by counting the number of pulleys. So 1, 2, 3, 4, 5. That means that the velocity ratio is 5. Or you count the number of rods pulling. There is this 1, this is 2, this is 3, this is 4, and this is 5. Therefore the velocity ratio is 5. So we shall come here and state that the velocity ratio is 5. So now we shall go to Roman 2. Roman 2 says, find how far the load is raised if the effort moves down by 4 meters. So this is the effort distance and it is 4 meters. So they want you to find how far the load is raised. So the good thing, we know the velocity ratio, so we shall come here and say that velocity ratio is effort distance over load distance. Now the effort distance was 4 and the velocity ratio, we have got it as 5. So we only have the load distance as the only unknown. Now when I cross multiply and make dl the subject, it will be 4 over 5, which will be 0.8 meters. So that was Roman 2. Now we shall go to Roman 3. Roman 3 says, calculate the effort required to raise a load of 800 newtons if the mechanical advantage of the system is 4. So mechanical advantage has no units. So we have a mechanical advantage and we have the load, so we shall come here and say that mechanical advantage is equal to load over effort. So I have the load, I have the mechanical advantage. I'll come and substitute. Then I'll make E the subject. So when I make E the subject, it will be 800 over 4, which gives you 200 newtons. So that was Roman 3. Now we shall go to Roman 4. Roman 4 says that calculate the efficiency of the system. So now that efficiency is equal to mechanical advantage over velocity ratio multiplied by 100. So I'll come and substitute for mechanical advantage and for velocity ratio to multiply by 100, and that will give me 80% as the efficiency. So that is how the marks would be awarded. So now we shall go to part B, Roman 1. Part B says, explain what happens to the efficiency of a system in B above if load is much less than 800 newtons. So you come and say that first of all, efficiency increases with increasing load and also decreases with decreasing load. What does that imply? It implies that if the load is much less than 800, the efficiency of the pulley system will be reduced because the proportion of the energy input that will be used in doing work against friction will increase. That is Roman 1. Then Roman 2, they wanted what happens if the load instead is much more than 800. So the load is much more than 800. It implies that efficiency will reaches a maximum and starts decreasing with increasing load. Therefore, if the load is much greater than 800, the efficiency of the pulley system will increase because the proportion of the energy input that will be used in doing work against friction will reduce. So that's how marks would be awarded for that slide. So that was part B. Now we shall go to part C. Part C says, draw a sketch graph to show how mechanical advantage of the system in B varies with the load. So first of all, we know that they have told us a sketch. That means that we don't need a graph paper. So that is the axis. Then we shall come and draw our curve. So mechanical advantage is equal to 5 because maximum value of mechanical advantage will be 5. It cannot exceed that. If it exceeds, it means that efficiency will be more than 100%, which is impossible. So efficiency to be 100%, it implies that mechanical advantage is equal to velocity ratio. Therefore, mechanical advantage can never exceed velocity ratio. That is why here we have 5 as our limit. But also you should realize that here there is no sharp bend. If the bend is sharp, then you will have lost the mark. So that was part C. Now we shall go to part D. So part D says, give 2 practical examples where pulley systems are used. So one, we have cassette tapes. They are used in cassette tapes. Then flagpoles. Next we have construction cranes. Then automobiles, conveyor belts such as grocery checkout, rock climbing equipments. They are also used. Automotive lifting equipments, dumb waiters, small elevators used in storage buildings. Then also ship equipments which use block and tackle pulley hoists. So here, any 2, you get yourself these 2 marks. You don't write more than 2, you write only 2, and make sure that here the curve is there's no sharp bend. So that was question 2. Now we shall go to question 3, which says, the diagram in figure represents a pulley system in which an effort E is applied to raise a load L. So this is the effort, this is the load. Copy the diagram and indicate the forces acting on the string. So we shall first redraw the given pulley, then we can be able to indicate the forces. So let's first redraw the given pulley. So the forces will be acting upwards. So on this string there will be that tension, on this string there will be that tension, on this string there will be that tension. So they are all facing upwards. So that was Roman 1. Now we shall go to Roman 2. Roman 2 says, what is the velocity ratio of the system? So velocity ratio, you count the number of ropes pulling or the pulley number of pulleys. So if you count the number of pulleys, there is 1, 2, and 3. That means the velocity ratio is 3, or you count the number of ropes, 1, 2, 3. So either way, velocity ratio will be 3. So we shall come here and state that velocity ratio is equal to 3. Then now we shall go to Roman 3. Roman 3 says, how far will the load move if the effort moves by 2.5 meters? So we have the effort distance and the velocity ratio. We can come and substitute that velocity ratio is equal to effort distance over load distance. So when I substitute for velocity ratio and effort distance, I'll remain with load distance as the only unknown. So when I make it the subject, it will be 0.8 meters. So that was Roman 3. Now we shall go to Roman 4. Roman 4 says, what effort will just raise a load of 960 newtons if the mechanical advantage is 2.4? So we know that mechanical advantage is equal to load over effort. So I'll come and substitute for the load and for the mechanical advantage, remain with effort as the only unknown. When I make effort the subject, it will be 400 newtons. So that was Roman 4. Now we shall go to Roman 5. Roman 5 says, use your results above to calculate the efficiency of the pulley system. So we know mechanical advantage, you also know the velocity ratio, so you can come and substitute and get the efficiency as 80%. So that is how marks would be awarded. So now we shall go to part B, Roman 1. So Roman 1 says, draw a sketch graph to show how the mechanical advantage of the pulley system in B varies with the load. So we should remember that mechanical advantage can never exceed the velocity ratio. So we shall draw a diagram so that the maximum value of mechanical advantage is equal to the velocity ratio, which will be 3. So that is what they wanted. Now we shall go to Roman 2. Roman 2 says, explain the features in the sketch in C Roman 1. So first of all, we shall say that when the load is small, the useless work done due to friction and the weight of the pulley blocks and the strings, or which we call unnecessary weights, is proportionately high. That is when the weight is small. What about when the load increases? So as the load increases, the work done to overcome friction and the unnecessary weights becomes proportionately smaller, and so mechanical energy increases but does not exceed 3. And the reason why it doesn't exceed 3 is because maximum mechanical advantage will always be equal to velocity ratio. So that is how the marks would be awarded. So now we shall go to question 4. Question 4, part A, Roman 1. Part A says, what is meant by Roman 1 velocity ratio of a machine and Roman 2 pitch of a screw? So the velocity ratio is the ratio of distance moved by effort to distance moved by the load in the same time interval. What about pitch? So I come and say that the pitch of a screw is the distance between any two successive threads of a screw. So that was part A. Now I shall go to part B. So part B says, a screw jack with a lever arm of 56 centimeters and a pitch of 2.5 millimeters. Note this one, this is millimeters and this is centimeters. Is used to raise a load of 800 newtons. If the efficiency is 25%, find Roman 1 the velocity ratio and Roman 2 mechanical advantage. So velocity ratio will be equal to the circumference over pitch. So circumference is 2 pi r, so pi can be, so here you can either use this or you use 22 over 7. It will be the same. Then here r is the radius, but you have to convert it to meters. Then one pitch was 2.5 millimeters. We have to convert it to meters, and that is done by multiplying by 10 to power negative 3. So when I divide, I'll come up with this, and then when I round off, I'll come up with that. So that is how the marks will be awarded. So now we shall go to part B, Roman 2. Roman 2 says they want the mechanical advantage. So we know that efficiency is equal to mechanical advantage over velocity ratio multiplied by 100. So I'll come and substitute for efficiency and velocity ratio to remain with this as the only unknown. So when I make M a the subject, it will give me this, which approximates to 352 as the mechanical advantage. So that was part B. Now we shall go to part C. Part C says, describe an experiment to show how the mechanical advantage of a block and tackle pulley system with velocity ratio 4 varies with the load. So velocity ratio 4 means that there are 4 pulleys pulling, and also the number of rods pulling will be 4. So we shall first draw a diagram with 4 pulleys pulling the load. So that is the effort scale pan. Then you also have the load scale pan. So let's first award marks for this slide before I go to the next slide. So because they told us the velocity ratio is 4, the pulleys must be 4, and here the number of rods pulling must also be 4. Now we shall start the explanation. So we shall say that known weights are put on a load scale pan whose weight is known. Then we shall say that other known weights are put on the effort scale pan until the load rises slowly with uniform speed. The mechanical advantage at this point is calculated from mechanical advantage is equal to load over effort. The procedure is repeated for a series of increasing loads and their corresponding efforts recorded and tabulated. A graph of mechanical advantage against load is therefore plotted. From the graph, mechanical advantage will be seen to increase with the load but does not exceed 4. Why? Because maximum mechanical advantage is equal to velocity ratio, and the velocity ratio was 4. So that is how marks would be awarded for this slide. So that was question 4. Now we shall go to question 5. Question 5, A Roman 1 says, define efficiency of a machine. So your command says that efficiency is the ratio of work output to work input expressed as a percentage. So now we shall go to Roman 2. Roman 2 says, give 2 reasons why the efficiency of any practical machine is always less than 100%. So the first reason is that some energy is wasted in overcoming the frictional forces between the surfaces of the moving parts. And the other reason is that some energy is wasted in lifting weights or useless loads of moving parts of the machine, such as the threads or ropes and the movable pulley blocks. So that was Roman 2. Now we shall go to Roman 3. Roman 3 says, state 2 ways by which the efficiency of a machine may be increased. So one is by lubricating moving parts of the machine in order to reduce frictional forces between their surfaces. Then 2 is that by using very light components in order to reduce on the weight of the moving parts. So that's how marks for this slide will be awarded. So now we shall go to part B. Part B says, figure 1 shows a mass of 30 kilograms being raised to the top of the incline. Then this is the incline, so they said, if the effort applied is 160 newtons, calculate the Roman 1 efficiency of the machine. So we have the effort distance, and the effort is 160. Then you have the load will come from this weight. So the load is the weight, which is 30, which is the mass multiplied by the acceleration due to gravity, which is 10, and the effort was given as 160. So in the end, you should come up with the mechanical advantage as 1.875. The length of the incline will be got from Pythagoras theory and will be 13 meters. Velocity ratio will be given by length of the incline over height of the incline. So length of the incline is 13, height was given as 5, which gives you 2.6. Therefore, now I have mechanical advantage and velocity ratio. I can now get efficiency. Efficiency will be mechanical advantage over velocity ratio multiplied by 100 to give you 72.115%. So that was Roman 1. Now we shall go to Roman 2. Roman 2 says calculate the frictional force. Frictional force is the same as energy wasted, which will be work input minus work output. So work done against friction is force times effort distance, and work done against work input will be effort times effort distance, then work output will be load times load distance. Therefore, when I substitute effort distance is that, effort is that, effort distance is that, load is that, load distance is that. So my aim is to make F the subject. So when I make it the subject, F will be equal to 44.165 newtons. So that is how marks for this slide would be awarded. So now we shall go to part C. So part C says that in the gear system below, N1 and N2 are the number of teeth on the wheels. So number of teeth on this wheel is 20 and number of teeth on this wheel is 100. If the shaft radii are 0.4 and 0.2, so this is 0.4 meters and this is 0.2 meters respectively, and the efficiency is 30%, find Roman 1 the velocity ratio. So now the velocity ratio is equal to number of teeth of the driven gear over number of teeth of the driving gear. Therefore, it will be N2 over N1, and N2 was 100, N1 was 20, which gives you 5 as the velocity ratio. So now we shall go to Roman 2. Roman 2 says find the load that can be raised by an effort of 200 newtons. So the good thing, we know the velocity ratio and the efficiency, so we are going to first calculate the mechanical advantage. So efficiency is given by that, and efficiency was 30, velocity ratio was 5, so therefore mechanical advantage will be 1.5. But I know that mechanical advantage is load over effort, therefore when I substitute and make L the subject, L will be 300 newtons, and that's the load they wanted. So that's how marks for this slide would be awarded. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on the solutions for Topical Test 2, which was already sent on this platform. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video with the solutions or test 2 has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.